In this video, I'm going to teach you a bit about the structure of a 4x4 cube, some new notation, as well as give you an overview of the solving method that we're going to be using for solving the 4x4. In this video, I'm going to talk about the 4x4 cube structure, some new notation, and give you an overview of the solving method that we're going to learn to solve the 4x4 Rubik's Cube. So a 4x4 cube has far more possible scrambled states than a regular 3x3 cube, and so because of the increased number of pieces, it's more difficult to solve. However, with a structured approach and a little bit of patience, it actually isn't too bad. As I mentioned in the introduction video, you need to be familiar with solving the 3x3 Rubik's Cube before you tackle the 4x4. The types of pieces on a 4x4 cube are broadly similar to those which are on a 3x3. So for example, on a 3x3, the centerpiece has one sticker on it, and on the 4x4, there are 4 of those centerpieces on each side. So for example, here on the white side, there are 4 centerpieces which each have one white sticker. So like we have edge pieces on a 3x3, we also have edge pieces on a 4x4. So for example, here where we have a singular edge piece, the white and green edge piece on a 3x3, we have 2 edge pieces with the same 2 colors on a 4x4. So we have this white and green edge piece, which has 2 stickers on it, and this white and green edge piece, which has 2 stickers on it. Lastly, the corners are exactly the same on a 3x3 and a 4x4. So here we have 8 corners around the 3x3, and we have the exact same 8 corners around a 4x4. So these are the pieces with 3 stickers on them that lie at the corner of the cube. One important thing to note is that the structure of a 4x4 is a little bit different to a 3x3 in that there are no fixed centerpieces. So for example, if we look at this side, there's no way of telling exactly what color this will be when we finish up, as opposed to on a 3x3, where the color of the center sticker of each side denotes the final color of that side. So in order to actually solve the 4x4 cube, we'll need to create the equivalent of these fixed centerpieces on a 4x4 cube, where the centerpieces are free to move wherever they want. So if you have a look around the internet, there are a few different ways which people will use to notate moves on bigger cubes. The convention that we'll follow here on the Cube Skills website is to use W moves to denote wide turns, like this, and lowercase letters to denote inner slice turns, like this. And note that when we previously used for 3x3 notation a lowercase u, that meant to turn 2 entire layers, but here on the 4x4, a lowercase letter only means to turn the inner slice. However, there aren't many occasions on which we'll actually use just the slice moves. So to show you a clear example, RW or R wide means to turn the 2 layers like that. A small lowercase r means to just turn the inner slice like that. And as on the 3x3, an uppercase R means to simply turn the outer face clockwise once. So the method that I'm going to teach you for solving the 4x4 is known as the reduction method, and the reason it's called the reduction method is because essentially we reduce the 4x4 to a 3x3 state. So the first step in our reduction method is to solve the centerpieces. So these are the pieces with only one sticker on them. What you'll essentially be doing by solving these centerpieces is doing the first step of turning this 4x4 into a 3x3. So here on the 3x3, we don't need to solve the centers because there's only one sticker on each center, and that denotes the color of the side. But here, because we don't have fixed centers, we need to form the centers ourselves. So I'll teach you how to do this in the next video, but after the first step, your cube should look like this, where we have all 24 individual center stickers around the entire cube solved into their respective positions. Hopefully from here, you'll start to see how we're reducing the 4x4 to a 3x3. So for example, these 4 pieces are equivalent to just one piece on a 3x3. So the next step in the reduction method is to pair our edge pieces. So here's what it looks like when we've solved one equivalent edge pair. So for example, on a 3x3, we have a singular edge, and here we've paired up this white and green edge as well as this white and green edge, remembering that there's only 2 which have the same 2 colors on them. So here's an example of a solved one, and now we need to do the exact same thing to all of the other edge pieces around the cube. So here's the only solved one at the moment, and we need to pair up, for example, this blue and orange edge with this blue and orange edge over here, because at the moment they're not in the same position like that. So here's what the cube will look like after we've done the second step of reduction, which is edge pairing. It will look a lot more neat and tidy because we've got all of these edge pairs matched up together like that. So now that we've solved all of our centerpieces and paired up all of our edge pieces, this cube is effectively now a 3x3. We can solve it in the exact same way that we do a 3x3. So for example, we'll solve our cross first like this, remembering that these two edges will stick together and we're only turning the outer layers when we're solving the 3x3. However, because of the extra pieces on a 4x4, you may run into situations which you physically can't encounter in a 3x3, such as having one flipped edge in your last layer, and these are things we'll deal with in the tutorial videos. So the 3x3 stage of the reduction method is the last step, and so after doing that, your cube will be solved. So in the next 3 videos, I'm going to show you solving the centers, solving the edges, and then solving the 3x3 stage on this cube.